Assalamu alaikum and a very good evening to everyone. We will wait for 2 to 3 minutes so that our participants join enough, and after that, we will start our session. So, kindly have the patience and wait for a few minutes. Thank you.
Miss Abeera, am I audible? Report, am I audible to you?
Yes, you are audible and clear.
Miss Abeera, you can start now.
Okay, I'm going first. Okay. Assalamu alaikum and a very warm welcome to everyone. On behalf of Veteran International Alliance for Sciences, I am delighted to welcome you all for the fifth session of Bioinformatics and Molecular Docking Online Internship Program 2026. I hope you all are doing well and enjoying your learning journey so far. Before we begin, I would like to make an important announcement regarding attendance. A Google Form link will be shared in the live chat during the session. All participants are requested to fill out the form carefully to mark their attendance. Now, it is my pleasure to introduce our estimated speaker for today's session, Miss Abeera Iftikhar. As we know about her from the previous session, I'm not gonna introduce her again, but I would like to invite her for the session and show her presentation as well. Miss Abeera, the floor is yours. Kindly start your session. Miss Abeera Iftikhar, am I audible?
Assalamualaikum. Yes, you are. Thank you so much. We're starting in few minutes. Just a minute. Let's start our session. Thank you so much for letting me be the mentor for this session. And let's start our session officially. Can you please move the slides? Today, the topic of our lecture would be the protein structure refinement. As so far in the previous lecture, we had covered the protein structure validation, and I had pretty much explained about why do we move toward the protein structure refinement if we had validated the structure beforehand, but still we will cover it in a brief way. So today we will be covering up the protein structure refinement, and the tool we are going to use for this purpose is GalaxyRefine. GalaxyRefine is a kind of interface or a server, we can say, that offers too many separate tools, but we are just going to use the Galaxy Refine for server for this purpose. And the session outcome will be we will be assessing of the quality of predictor structure, or either if the structure um, resolution isn't good, we have to move toward the refinement for this purpose too. Next slide, please. So, what is basically protein structure refinement? Why do we have to refine our protein 3D structure? Let's say we can describe it as like we have to improve the predicted structure. Either we had predicted it using any kind of separate softwares or the tools. If the 3D structure isn't available, we have to predict it using the different tools and the software. And if the 3D structure of protein is available, but the resolution of that 3D structure of protein isn't good, or isn't falling into the range of that is considered good, so we have to move toward the refinement of that structure, so that afterwards we can move for any kind of downstream analysis. So we can say that in an easy way that we have to improve our predicted structure or either the low resoluted structure, and correct up their geometric errors, any kind of chain-to-chain confirmations, or any kind of static clashes. We have to reduce them, so we can overall enhance all of the structural ability. So we can move toward or obtain any the better one or more realistic model. So these will be the objective of the structure, like so these will be the objective of the structure. We have to improve the structure accuracy, and we have to overall modify or stabilize our model. We have to optimize our side chains or confirmation. We have to change them, and if there is any kind of repacking stability available, we have to move toward that. So we can correct up there any kind of steric clashes and any kind of geometric error. Next slide, please. So why the first question is that came up in your mind is why we have to stabilize our structure, and what is structure stability? Like if the structure is available over to the interface or over to the database of PDB, why do we have to move toward the stability? Why do we have to check the stability before moving toward any kind of downstream analysis as for the program is going to move toward the docking? We have to measure if the protein or we are going to use for any of the further analysis is it stable one, or either are the bones, bond length, their atomic interactions, their residues, or any kind of non-bonding interaction, are they stable? Or because the stability will lead you toward the better prediction or better results, better docking results, rather than going toward the backward way. And the stable structures usually moves you to the good docking scores. So if you don't go for any kind of structure refinement, if the resoluted your PDB structure or the 3D structure of your protein have low resolution and you don't move toward the refinement, you directly move toward the using it for the docking purpose with a ligand, or either you are using it for another protein. And this will lead you toward the poor docking scores, and you yourself have to move back toward the refinement and then validation process. So all of these will take you back toward the refinement. So make sure you take a note about the resolution range. If it is falling within the range of 0 to 2, then it is good. You can use it for directly after the validation check. But if it is crossing up the line of 3 to 4, or it is falling into the region of 2 to 4, we have to move toward the refinement and we have to go for the validation. You can even compare up the pre and the post refinement structures. Next slide, please. So we can also say that the very important question in this swing is why refinement is important. Like we can move blindly like that. Nobody will ask us, and nobody will get to know that we had skipped any kind of refinement of our structure. But the results will do that. Because whenever you are going to design any kind of drug, each and every single step should be cautious. Because whenever somebody or the lab scientist is going to implement or prepare that drug using your manual, you should be considered as the guilty one if you haven't worked properly over your whatever project you are doing. So make sure don't skip any kind of step. And these are all the cross-check values or the cross-check procedures. There are steps you can do to make sure your work is staying in a good line. Besides this, you have to check for any kind of if the structures are contain any kind of inaccuracies. Through this, you can check if it produces more native like conformations.
Miss, you are not audible. Due to our sun right now, we are giving a small break. After the sun, the miss will start the session again. So kindly be patient, everyone, and stay in the session. Thank you.
Okay, thank you so much. Let's go back toward the lecture. As the next thing is, what are the structural issues in a predictive model? Or we can say also in a low resolution or the poor resolution model. There will be the structure classes or any kind of incorrect bound angles, any kind of side chain wrong conformations. We have to reorganize them using the Galaxy server. As there are many more tools for this purpose too, but the Galaxy one is considered the good one as it is cited over many papers directly, and so that we can also write it in a report or the research paper we are going to write for that purpose, it will be acceptable. Next slide, please. We are going to operate this with a GalaxyRefine, but you can also go for Rosita Relax and the Mode Refiner. These two were considered good ones. Approaches. These are the approaches in the protein structure refinement. We have to fix up the energy and all along with the hybrid refinement methods. There will be many more methods, like we have to change up the simulations. We can go and check for the rotamers, or along with the results will show us the Ramachandran favor region, like the RC plot favor region results. So we can predict it like with the good RC results. As I had explained in the previous lecture, that the validation and the refinement is quite related with each other. Next slide, please. So this one is already covered, but still press. So with the refinement, we will improve the structure stability of our protein, or site-to-site chain conformation over geometry. If there is any kind of geometric error, we can improve that. But for that purpose, we can also say that if the validation ensure the structure is suitable for the molecular docking, keep that in mind that the refinement structure uh, can also go for the validation afterwards too. You can compare up the pre-validated validation results and the post-validation results to check if the refinement or the structure is refined enough or not. Next slide, please. So, GalaxyRefine we are going to use, as I had already explained, that Galaxy is a web-based server. It offers many tools, site tools, but we are going to use just GalaxyRefine for this purpose, and we are going to rebuild the side chains or any kind of um, errors. We are going to fix it, and we are going to do this with using the structure relaxation for the simulations. Next slide, please. So here is the workflow. We are just going to upload the 3D structure of protein whose resolution isn't good because I don't think so anybody had covered up the predicted one wing. So we will be going for the poor structure, poor resoluted structure, and we are going to refine it using the GalaxyRefine tool. We are going to improve the sidechain and the structural stability along with all of these inputs. Input file will be your PDB file format, and the output will be given to you in a table. We will explain it ahead. Okay. Can I share my screen now?
Yeah,
Sure,
please share the screen.
Oh yes, just a minute. Okay. So previously I had explained that this PDB structure I am going to use for the demo purpose. Here is a protein that is used as the protease for the HIV virus, and we are going to use this protein. This offers the 3D structure along with this, but we are going to improve up the resolution of this model. Like here I had explained, and I hope so you had covered up in the PDB database lecture, that the resolution is the most important one in the PDB. If the resolution falls in the range of 0 to 2, then you don't have to move toward the refinement. And if it falls between the category from 2 to 4, you do have to move toward the refinement. So we are going to move toward the refinement to improve this resolution of the image of your PDB structure. So we are going to download this, and I had already downloaded it. This offers only a CIF format. You have to change it into the PDB format and upload it toward the Galaxy server. Here is the Discovery Studio we are going to use again. We have to open up the file. So here is the 3D structure of protein. As I just have to save this model into the PDB format, I will go with the save as. It will give me an option from the drop down menu, and I have to select the protein PDB structure. Save as. Protein data bin file to save up your work here. Here, let's go with the Galaxy Refine. Galaxy Refine server. This is how the interface look like. The GalaxyRefine web or GalaxyRefine server, you can say. It is a server that I had explained that Galaxy is a server through which we can go for multiple things, as we can go for the protein structure prediction, even the refinement, and in many of the related methods. But right away we are going with the Galaxy Refine. Here you have to place your job name. Like I was going to use this protein, so I am placing the name of protein. Along with, you have to place up the email ID of yours, email address of yours. So if it is going to take little bit more time than you think, then you can place up your email address over here. Even if you close up your laptop or this interface or your system, it will give you the result of your work over to your email address. So make sure you upload your email address over here. Right here you have to choose a PDB structure or PDB file. It's Discovery Studio PDB file, and I am uploading it like this. Besides this, there's nothing to discuss, as these are all the examples or view report, but we are going to view our own report. We have to submit it. These are the results. Okay. This is going to take time. Average runtime is 1 to 2 hours if the email is given. Sometimes the server is busy, it will take 1 to 2 hours, and sometimes the server isn't busy, it just take few minutes to cover up your work. We will toward the demo one. We just wanted to understand the results. In this way, you can go with the work. I have to view the report. It will give us this type of report along with the better 3D structure. So this is the example one. We can understand it from this interface, as our work is going to take 1 to 2 hours. So, and this is the 3D structure of our protein, the refined one 3D structure of our protein, and it will give us that table like this with the 5 models. Like we had given the Galaxy server our poor resoluted model or our predicted model to check for or to refine this model. It will give us the 5 models back. Like all of these models can be downloaded. You can download all of these models. Besides this, make sure you have read the graph or the chart. It is offering us that here is the total result, and from this result you can check or predict like which model you are going to use for your further working. It is giving us the 5 refined model of our work or of our input model. Like here you can see RMST is the root mean square value, and the first thing we considered is the Rama favored regions. Rama favored regions are just like RC plot. It is the same results of RC plotting. So the first model gave us the very best results, like 99.0%. Here the first initial is considered as our query, and the query is also showing us the good results. And besides this, all of these models are quite falling in the most favored region with the very good Rama favored results. So make sure most of the time we pick up the first one because it offers the best one results of Ramachandra plot. So you can simply download it from here. It will be downloaded in your system, just like this. You can use it for the further analysis. Either you want to refine your all of your models, or either you want to go for the validation afterwards again. Like you want to check for the RC plot, proper plot, or the errat proper plot for placing in your um,
Uh,
research paper or the report.
Miss, sorry to interrupt you, but I guess you got some background noises and it is distracting your own voice. So, do you like to take a note on that?
Um, there isn't any kind of background noise from my side.
Yes, yes, there's a
Isn't my
background.
voice isn't my voice clear? I right now I haven't have any kind of background noise.
Your voice is clear, but background noise is making a little bit unclear.
Okay, that's all from my side, as the results of our work is going to show up in 1 to 2 hour, and I had explained it from the model 1 results. So let me know if anybody have any question, or we can move back to the slides, Miss. Can you move the slides so I can check what is left? We had covered up this and this too, along with, yeah, wait a minute, this previous one. Yeah. This is the thing I was describing, that you have to check for before and after refinement results. You can compare up using the validation results of yours, or either you can compare up using the refinement results. Like the predefined model shows up this RC plot result, or the post refinement result shows up this RC report results. So we can go with any kind of comparison like this with the structural quality, and you can check for the visual presentation of your improvement along with the proper cited or proper um, plots of yours, along with the importance of selecting up the best refined model. So make sure the model you are selecting have the best um, Rama favored region, as all of these are giving us the best Rama favored region, but we are going to pick one as it shows us the poor rotamer. So make sure whenever you are going to pick one model, it shows us the poor rotamer as poor as it is possible for this chart, and the good one Rama favored regions. Next slide, please. So these are the applications of refined models or refined protein structure. We can use them for the molecular docking, and it is validated one. And we can also move toward the drug discovery or the protein ligand interaction studies. This will give us the best docking score, and afterwards we can move toward the other further analysis or the simulation analysis. Next slide, please. So this is all about the protein structure refinement. We are going to refine up the quality or enhance up the quality or reliability of our predicted or the low resoluted protein structure. So we can move it toward the better downstreaming analysis, and we can get the better results. So it is a most important and the crucial step. Nobody is going to ask you if you had done it or not, and but you have to keep in mind that you are going to do this for your own security. You don't, so that you don't have to move back toward the refinement and the validation after getting the bad docking results. So refined models are considered the more accurate one for the docking purpose or the docking results. That's all from my side.
Thank you so much, Miss, for your insightful and practical session. I hope our participants got the valuable insights as well as the directions where they can have their answers. Right now, we will move for Q&A session. If anyone have any questions, they can write in the chat and I can bring it to you for the answer. The first question we have is, how does refinement affect drug discovery and enzyme engineering?
How do refinement affect the drug discovery and the enzyme engineering?
Yes.
I has already explained that the refinement predict up the good docking results, so we can affect it can affect up the drug discovery procedure, because as long as it is going to take up for the procedure, if you haven't refined your model, you are directly moving toward the docking with the unrefined model, that you are just wasting your time. You literally have to move back toward the very first step even after doing hours of work.
Okay, the next question we have that if GalaxyRefine improves the EROT score and Ramachandran statistics, but the RMSD from the original structure increases significantly, which model should be preferred for docking?
So even if the GalaxyRefine improves up the score with the RC plot or the Iraq value, RMSD, we can say that it can be significantly increased. Like here, we can check these are all the RMSD values, and these are bare minimum right here. We can see 0.3 to something like this. It it doesn't elevate to the more increased version, so it also stays to the bare minimum values.
Okay, we have another question
You have
is,
to pick up.
yes,
Miss,
Miss.
go ahead.
Okay, I have another question for you, which is, what are the major limitations for protein docking when dealing with highly flexible proteins?
Major limitation of protein docking when dealing with a highly flexible protein. There are multiple type of limitations in a kind of protein docking. If you are going for the protein to protein docking, there are two ways of, or the two types of docking. Either you are moving toward the rigid docking, it doesn't offers the flexibility in a structure. And if you are moving toward the flexible docking, it offers many type of flexibility in the structure. So we can say that if you are using the multiple proteins to dock with the multiple protein, single protein as a protein and the several small protein as a ligand. For the flexibility docking style, it will move toward the many of the limitation, as there will be multiple sites. The multiple protein, small protein are going to align or bind with the major one protein. As for the protein interaction for the docking, it can mess up.
The next question we have that can protein refinement ever reduce protein accuracy by changing the native conformation of the binding pocket?
No, it doesn't work like that. If you are going for protein refinement, it doesn't reduce docking accuracy. It actually improves up your docking accuracy, because if your model isn't refined, or you have predicted of the 3D structure of model, it doesn't exist on the PDB interface, and you haven't checked for any kind of validation or refinement, you have directly moved toward the interaction of protein ligand or protein to protein. Whatever you are doing in this one, it will definitely affect your docking accuracy or docking results. And the pockets you were asking about will not form as the way you wanted.
Okay, the next question we have: what metrics are used to evaluate refinement quality?
There are multiple things we use for the elevation of refinement quality. Like whether we are going to refine our the side chains. Mostly, whenever we move toward the refinement, it directly unpack our side chains or improve the structures using the simulation relaxation techniques.
Thank you, Miss, for clearing the confusion. We have another question, which is what PDV structure was used in this class?
PDB structure that we have used in the class is 1HPP. This is the PDB ID, and this is the three-dimensional structure of aspartyl protease enzyme of HIV.
Thank you so much. I don't see any question left, so we can conclude the meeting as we came to the end of our session. Thank you for your insightful session and your practical hands-on training as well. Protein structure refinement was a very important session for the participants for this internship. Thank you to the participants as well for being attentive, listened carefully, as well as asking valuable questions. We look forward to seeing you in our next sessions, and the attendance link was given to the chat box. So kindly fill it for and mark your attendance. We are gonna end this session. So until then, stay curious, keep learning, and continue your journey towards scientific excellence. Thank you, everyone, and thank you, our estimated speaker, Miss Abeera Iftikhar, as well. Allah Hafiz.
Thank you so much.
Sir Gulam Murtaza, kindly end this session.
Hello, hello, am I audible? Miss no problem.
Yes, you are audible. Kindly end the stream because the session is completed.
Okay, thank you so much, everybody, and thank you so much, Miss Abeera, for taking the floor and for wonderful session. I just want to give you the some little bit about the report, like how you will prepare the report. As in orientation program, basically the purpose of orientation program was that, like many students asking again and again, like how we will prepare the report. So for report purpose, for example, you are taking the class, you must have to take the screenshot, and then you have to make a professional post on your LinkedIn, on your Insta, on your any account. Okay, must mention the Vitano International Alliance for Sciences. After that, you have to prepare your soft report. Just like I am sharing one sample. Uh, Give me a minute. Uh, This is, as you all can see, this is the report sample, and you have already we have shared that report sample into the group uh, for as a sample. Like you have to prepare your report just like that. Yeah? First, it will be your name and somehow interface. After that, your certification, just like that. After acknowledgement, okay? After that, you will start your content, okay? And after that, you must have to add the introduction of the organization where you are doing the internship, and here you have to add the leadership unit as well in your report. Those are making that type of project and internship. These are ongoing and previous some projects. These are our international collaborators whom we are uh, discussing and organizing the international opportunities. That is summary of your. So just like that, for example, you take first lecture related to introductory but bioinformatics. So you will write your template title. You will here explain like what you learned from first lecture, and after that, you have to put here the screenshot of your uh, your post that you upload on your LinkedIn or Facebook or any account. Yeah. So in that way, you have to complete or report like second session. That that post is very mandatory in your report. Okay, you must have to take screenshot. You must have to make professional post. Okay. Uh, After that, you have to just like that third, fourth lecture. Each lecture you have to design just like that. And before starting that, you must have to add these things that are very important in your report. That's why we share that sample as a sample in your internship group as well for your better understanding. You have to review it and you have to prepare your report as a showcase of your wonderful journey at Vaitanawa International Alliance for Sciences as an intern. So the best report we will recognize, and we will give a special recognition to them, those people. Thank you so much, everyone, for the better understanding. I hope everything is clear now. And now we have to close it. No worker, please give the closing remarks, and then we will conclude it.
Thank you everyone again for your time and attention. The attendance link is provided, so I hope that everyone marked their attendance as report description was already discussed and it is discussed again with the practical streaming. I hope everyone got the point how to do the report and how to post your LinkedIn profile as well. So if you have any confusions, you can reach out as well after this meeting. And everyone have a great time. See you in the next session. Till then, stay healthy, stay wealthy, and gain knowledge. I love this, everyone. Sir, kindly in the streaming.